Hi, welcome to the 2 gram lab prep video. Today we're going to walk through what we need to do to make our scientific experiment successful in our 2 gram lab. In front of me I have my equipment. I have my filter paper, beaker, stirring rod, my flask, my funnel, my chemicals, both my hydrate and my carbonate, my weighing paper, my scoopula, and my distilled water. I forgot about my graduated cylinder right here. So the first thing that I need to do when I start out is I need to write my name on my filter paper. Now, all of the people in the group or the group name should have their name on the paper. Once I've completed that, I'm going to find the mass of my filter paper. So I've already turned on my balance, and I'm going to place my filter paper on my balance. My filter paper is showing me a mass of 0.68 grams. I'm going to be sure to document that in my data table right away. The mass of my filter paper, now it changed a little bit, is 0.69 grams. The next thing I'm going to do with my filter paper once I've documented the mass is I'm going to fold it so that it fits into my funnel nicely. The funnel is round and our paper is also round, but it needs to make a seal, and in order to funnel we need to have it folded properly. There's different methods. The method that we're going to choose to do is fold it until you can't fold it anymore. So you fold it many, many times until you squeeze it so hard you've got enough creases. It's this little tiny thing right here. And then I'm going to set it out and I'm going to unfold my filter paper. What this is going to do is it's going to make a lot of little channels for my paper when I am filtering. Okay? So on our instructions in our lab, it also asks us to moisten our filter paper. Whoa, I'm going to wipe out some glassware if I'm not careful. So I'm going to moisten my filter paper, and then I'm going to put my filter paper against the walls of my funnel very nicely. Okay, so I'm going to open my filter paper and create some channels. Notice that that distilled water is just dripping out a little bit. Okay, that's not going to hurt my lab bench at all. So now I've got channels where I can funnel whatever precipitate I create. Okay, so now my filter paper is ready to go. I have a nice little pocket. Now be very careful when you're using filter paper not to put your stirring rod in it and poke a hole in it, because then it's not useful. We don't want to have to add another filter paper to our experiment. All right, so now I've got my filter paper ready to go in my funnel. The next step is to measure out the hydrate that I want. Now we have already calculated the mass of the hydrate that we want using stoichiometry. I'm going to be using barium chloride dihydrate. Barium chloride dihydrate's mass to produce 2 grams of product is 2.48 grams. So in order to do this, we use weighing paper on our balance. Place the weighing paper on the balance, 0. So it should read at 0.00 grams. And I'm going to weigh and get the mass, there we go, of 2.48 grams. Voila.
That was
2.48.
pretty perfect.
Miss Bain, I couldn't have done that again if I tried. All right. So that 1 scoop was an exact 2.48. I am going to document this as my barium chloride dihydrate in my data table. What if we would have gotten 2.50? Would that be a huge problem? We have to document it in our data table for sure. But we want to get as close to 2.48 as we can because we want to see how our experiment is going to go. We have calculated that this should be the amount of reactant that we need to complete this reaction. So I have my 2.48. The other thing that I'm going to do at this point is take a very brief moment and in my observations document what I notice about this barium chloride dihydrate. What color is my barium chloride dihydrate? Well, first off, it's white. It's got a little bit of shimmer and it's in the solid state. Now those, color and state, those are our bare minimums, right? So we want to have white, solid. I could go on to say they're small crystals. And they're somewhat reflective of light. Those would be my observations. At this step, I'm going to remove my filter paper and I'm going to place my compound into my beaker. Okay, so I have completely cleaned off my filter paper. All of my compound is back into the beaker, and then I'm going to add approximately 20 milliliters of distilled water. This is our excess reactant, so we don't have to be as precise with this as we were with our barium chloride.
This is your barium chloride.
Oh, this is my barium chloride.
So this is your limiting reactant.
Limiting reactant. But we can say that we have 20 milliliters right there.
Right.
And then I need to dissolve this. I don't need to be as careful with the water as I was with measuring out my hydrate.
There you go. The water's not a reactant here, so it doesn't affect the calculated amounts of substances that you're using.
Sorry for my misspeak there. I was skipping ahead in my reaction. Okay, so I'm going to stir this up until all of my reactant, my barium chloride dihydrate, is dissolved.
So while she's dissolving that, recall that the reason it has to be dissolved is because that's what frees up the barium and the chloride ions so that they're free to react with the second reactant. Solid ionic compounds are not very reactive because they form a tight crystal lattice and they're very stable.
I think I'm going to add that additional 5 mils here that's in your optional instructions because mine is not dissolving at a pace that is useful. Okay, so we don't want to add too much. Why not, Miss Bain?
Glad you asked. It's because eventually all of that liquid is going to have to be filtered through the filter paper, and the more water you have, the longer that filtration process will take.
Okay, so I think I've got all of my compound dissolved. It's not quite as colorless as I'd expect at this moment, but it is no longer a solid in the bottom. So we're going to proceed with our lab, okay? Because all of the solid is off of the bottom of that beaker. It's in our solution. Okay, so the next step that we need to do is we need to measure out, and I'm going to be careful not to set that too far. There we go. We are going to measure out the volume that we need of our excess reactant, the sodium carbonate. Okay. So I'm going to use my graduated cylinder, and I have calculated that I need 10.1 milliliters. 10.1, somehow we have that documented wrong from...
No, 10.1 was the amount that you need. You want a little bit excess, and then you recorded the...
Got it. All right, so 10.1 is the minimum that we need, and then we'll go a little bit further. Okay, so right there I have a 10.1 volume of my sodium carbonate. I'm going to add approximately 5 more milliliters, okay, to make sure that I've got excess reactant. Right about there. This is what I'm going to record now. I have 14 milliliters of 14.0 milliliters of 1 molar, and be sure you document your concentration, 1 molar sodium carbonate. I'm also going to take this opportunity, before I close this step down, to document my observations about my sodium carbonate. This is in what state? It's aqueous, right? So we have an aqueous solution of 1 molar sodium carbonate, Na2CO3. And I'm going to call that clear and colorless. Remember, our abbreviation for aqueous is AQ. So make sure that when you're working with your compounds and your solutions, that you close them up appropriately so that you don't change the concentration of your solution and you don't have any contamination in your chemicals. So now I'm done with these guys. I'm just going to set them off to the side for the moment. I have my beaker. I'm just going to give it a little bit more of a stir. And I have my reactant. And at this moment,
I'm just going to add, it's possible that the reason it's so cloudy is because there was something contaminating left behind in the beaker that's contaminating the solution. So if this happens, you might want to dump it out, rinse it again really well, and remeasure your solid into the water. But since we're kind of in a rush today, we're going to go ahead and continue with the cloudy solution, but yours shouldn't be quite that cloudy.
it's not going to make it as dramatic.
True. You want me to stop?
Well, that just means we're starting over.
No.